Good morning, everyone, and welcome to this morning's New to 2016 webinar. My name is David Zabka. This morning what we're going to be covering is a new roof frame custom member that is available in 2016, as well as the part library in 2016. So we're going to start off with the roof frame member. And the roof frame member is a custom member, like I stated. So the way we would get to that is we can either use our model pull down menu, go to member, go to add, and then we can choose prompt for member type, or the shortcut key for that is F2. So I'm going to use my F2 key on my keyboard here to make things a little quicker. And we should have in there then a roof frame. Now, probably want to set up a few construction lines to make sure I get this input correctly here, so I'll go ahead and do that first. And I'm just going to offset a construction line here from my grid B. I'm going to actually go 10 feet to the right and then another 5 feet here for reference. And again, to add that custom member, it's F2 on my keyboard for the member add prompt and roof frame. Now I'm going to need to pick 2 points for this roof frame member. And before I do that, just want to explain that there's going to be several different parts that make up this roof frame member. And understanding the different parts is going to help us as we get into the member edit screen to know which settings we need to change. So there's going to be what we consider 2 primary supports. A primary support 1, which is going to be the support that runs parallel along the member line, or the 2 points that I'm going to pick. We're going to have a second primary support, or primary support 2, which is going to be offset to either the near side or the far side of the 2 points that I pick. And then we're going to have up to 5 secondary supports that run perpendicular to the primary supports. So I'm going to use intersection construction line and member to pick my 2 points here right between the 2 beams that I already have modeled. And if I just slide the edit window off to the side for a minute, you can actually see the member line, or the outline of this roof frame member that's going to be added in there. So the 2 points that I picked, that's going to be the primary support 1. The other line that runs parallel to that but offset to the far side in this case is the primary support 2, and then the 2 lines in between are the what we currently have 2 secondary supports, but like I said, we can have up to 5 of those. So back in this edit window, up top you just have your general settings for piece mark prefix, your sequence, all your typical things that you might have for members in there. You have your model complete date, work point to work point length options off to the right. You have a frame rotation option here, which we'll cover a little bit later. You have an opening side. The secondary quantity, like I said, you can do up to 5 secondary supports here. Now we do have a 0 option in there. If you were to pick the 0 option, that's just going to give you the 1 primary support, and this could be used in maybe a corner opening where you just need the 1 primary support. We'll cover that a little bit later here. Then you have some general primary support settings, dimension between the primary supports, your left and right end elevation. In this case, it was filled out based on the 2 points that I picked. Then you have the size of the primary 1 support and the size of the primary 2 support. I'm going to go ahead and leave all these options blank as they are for right now. We'll come back and start changing things so we can see what happens. I just want to take a look at the roof frame member here for 1 minute. So I'll click OK, and there we get our roof frame member. So again, we have our primary 1 support that runs along the 2 points that I picked. Our primary 2 support in this case is on the far side, and then we have our 2 secondary supports running perpendicular to those. So that's what we have for right now. Again, going back, if I just turn this back to a stick form, notice that it's not just one straight stick line. It actually gives us the stick lines where all the supports are located and everything. This is going to be useful on our erection views if we're detailing in stick, because then we actually get a little bit better representation in our stick form. So I'm going to change this up a little bit so that the opening actually comes in here between my two construction lines that I have set up, and these construction lines are 5 feet apart. So what I would want to do is go ahead and edit this roof frame member, and my opening side right now is far side, so I can go ahead and change that to near side. And then the dimension between primary is going to be the dimension between the primary 1 and primary 2 supports. So I'm going to change that to 5'0". Click OK, and there we can see how that changed then. Now the other thing we can do, we can locate our different secondary supports a little bit differently than what we want or what we have here currently. So if I edit that and I come down below the primary support settings, I'm going to have a left end settings and I'm going to have a right end settings. That's going to be for the connections, which we're going to cover a little bit later. So I'm just going to go ahead and turn those off for now. And I'm going to focus on the secondary support settings for the time being. So right now we have a secondary quantity of 2, so we're really only going to worry about secondary 1 and 2 here. Right now you have a dimension for secondary 1 of 2 feet, and that's going to be from the first point that I locate when I input this member. That first secondary support is going to be 2 feet. So from my point that I picked down here up to the first secondary support, in this case, is 2 feet. And then the next secondary support, secondary 2, is going to be located from the previous one. So secondary 1, it's going to be 2 feet. So I'm going to go ahead and make some changes there. Let's say I want secondary 1 at 1 feet, and then secondary 2, I want 4 feet from secondary 1. Okay, and we can see we get those changed a little bit. Now, our toe directions, we can see right now they both kind of go in towards the opening. If we wanted that opposite, we can go ahead and change that as well. So I'll go ahead and double click that. Notice we have our section size for the secondary supports, 1 and 2. If you had an unequal angle leg, you could choose the long leg to be vertical or horizontal. In this case, we're kind of after the toe direction. So maybe in this case, I want the secondary 1 toe direction to be in and the secondary toe direction 2 to be out. Say OK, and then there we can see that flip the toe direction for us. You probably notice currently that we're not receiving any welds on there right now. The reason for that is if I go ahead and edit this roof frame member, we can see that our weld sizes specified here are 0 currently. Okay, I could go ahead and change that, type in whatever weld size I need. It should give that to me. But we should also know that there are setup options for this roof frame member. And those setup options can be found under your job options. Since this is a custom member, it's technically a plugin. So we can go down to plugin options, and then we have plugin options for our members. I'll specify which member plugin options I want to change. That's the roof frame. And our window is going to look very similar, just a little bit different. It's basically what it does is it's a pared down version of the member edit window that you see in modeling, because there are some options that you need here, but you don't necessarily need all the options to be able to set them up. So it's very similar but a little different. As you can see in here, all your different weld sizes are set to 0. So I'm going to go ahead and just set this up for quarter for my weld sizes. And you could go through there, like I said, look at the different settings, change different things in here. Since this is a plugin, I'm going to need to close modeling and reopen for those changes to take effect. I'm just going to go back to my roof framing plan, and now I'll add another roof frame up here above the other one, just so we can see. I'll kind of make it the same as what we had previously. Now you can see for my secondary support, I'm getting 1/4 filled out for the weld size. That's because it's now reading from those setup options. And then when we rotate around, we actually see the welds coming in there then. I'm going to get rid of that particular roof frame for now and go back to the first one that we input here. Now remember, I can input more than just the 2 secondary supports. If I need 3, again, I can do up to 5. So there I did 3. It located it incorrectly, but that's kind of on me because I didn't adjust my dimensions down here. Okay, so there we have 3 secondary supports now if we needed. I'm going to go back to 2, change my settings back up again here. Back to this. Okay, so that's kind of just the basics of getting your roof frame laid out as far as how to locate your primary 1, primary 2, and then your secondary supports. The next thing we want to look at here is our connections to the supporting members. So we have 3 different connection types that we can use. We have a saddle clip option, which is what we see here currently. We can also just set to a plain end. That's going to set the primary supports, just going to cut them back a clearance that's specified. Or we have an option to strip the vertical leg and have the horizontal support leg sitting on top of the supporting members. And I should back up a little bit. Everything that we've seen here is done with angles for our material. You can do different material types for your supports. So for like your primary 1, you can do channels, HSS, really whatever you need. So if I wanted a channel in this case, maybe a C6x13, I can go ahead and change that. Say OK, and there I'm going to get some channels. My saddle clip probably isn't correct in this case, but you could see there then that we can do different material types for the different supports. Same with your secondary supports. You could do channels, HSS, whatever you might need there. So I'm just going to go back to the angles here again. Just wanted to make sure everybody understood that. Okay, so we got our angles here. We're going to look at the saddle clip connections next. Okay, so for our connections, they're going to be a little bit different than a typical beam or column, and the reason being is you're going to have 4 connections instead of 2. So you're going to have a left end of your primary 1, you're going to have a right end of primary 1, left end of primary 2, and right end of primary 2. So if I edit that, I'm going to turn the secondary support settings off and turn my left and right end settings on. Notice under the left end then you have primary 1, primary 2, right end you have primary 1, primary 2. Indicated in there is going to be the supporting member number. You have your connection type. Like I said, we could do saddle clip, plain end, or strip vertical leg. Specify the size of that saddle clip, whether the long leg's vertical or horizontal. Then you have the length of the angle. So I'm on primary 1, the left end. Right now it's 5 inches. Just for argument's sake, I'm going to show you 1 foot. We can see we have the 1 foot there. I'm going to go to a top view here so we can see it a little better. Now, we also have a vertical offset and a horizontal offset. So the horizontal offset is going to offset that perpendicular as we're looking at it here to our primary support. So if I were just to go ahead and set that to 0, okay, we can see that what it does is it sets that or begins the angle right at the points that I picked, and it's going to put the length away from my primary 2 support. Okay, so if I come back in here and change this to a foot, it should move it 1 foot to the right towards my primary 2 support. And I can put a negative value in there too to kind of force that one way or the other if I need to. Just want to kind of demo that. Your vertical offset, so your vertical offset is actually going to be the distance that that saddle clip is set up from the top of your support. So in this case we have 1/4. It's really just setting it up 1/4 inch, which is the thickness of this angle currently. If I were to change that, and this is going to be my primary 2 left end in this case, I can change that to 1/2. Okay, adjust my depth check a little bit so we're not seeing what's in the background there, and we can see that angle was moved up another 1/4 inch. Go back to auto there. Again, you have your weld size, field clearance. So the field clearance for your saddle clips is going to be the distance from your supporting member's flange to the inside of this angle. So if I were to go ahead and change this to 3/4, should move that out. And if I were to add a couple construction lines here and measure that, we can see we got 3/4 of an inch there. Going to go ahead and change that back to our 1/2. Okay, so now some of you may do things a little bit different, or there may be situations where instead of doing 4 separate saddle clips, you may actually want just one that extends the whole length of that roof frame. That is possible, kind of in a little bit of a roundabout way, but what I can do is use just my primary 1 saddle clips and set those settings so that it extends all the way across. So what I'm going to do in this case is just set my primary 2 connection types to a plain end. Then I'm going to make adjustments to my saddle clip up here. So for the length of the angle, I'm going to have to specify that it is at least the dimension between the primary supports. So it's going to be 5 foot. And then I want it to extend at least to the outsides of my primary 1 support angles. In this case, they're 4 inches. So I would add 4 twice, so 5 foot plus 4 for each primary angle, and then add the overhang, which in this case I'm just going to say it's going to overhang 1 inch, so add another 2 inches. So we got 5'8" plus the 2 inch overhang. The length of my saddle clip down here would be 5'10". And then I'm going to want to go ahead and adjust this horizontal offset. So that then I'm going to want to adjust that, offset it the length of my saddle clip minus the angle leg, which is 4, minus the overhang, which is 1. So 5 foot minus, so it'll be 5'10" minus 5, minus the angle leg, minus the overhang. Excuse me, I think I told you wrong. It's going to be 5'5". And just to kind of show you what that looks like, that's what we're looking at there. Okay, I can go ahead and do the same thing for my right end. So again, we had 5'10", and then the horizontal offset is going to be 5'5". And there we have just 1 saddle clip then that extends the whole way across. One other thing we have to watch out here for then is I did a plain end over here on this primary 2 support, and right now we can see that that interferes with the clip that we had extend across. We can fix that easy enough because we have a field clearance down here. Right now it's at a half. That's what the field clearance is up here, so we just need to adjust that by the thickness of my angle. So we need to add a quarter there and do 3/4 or 0.75, and now we can see we don't interfere. The one thing you may not get here in this case is once I fill out my weld information for my saddle clip, it is only going to weld it to the primary 1 support. We don't get it welded to the primary 2 support. So a little bit of a drawback there, but so that's the saddle clip connection and just a plain end connection. We'll look at the strip vertical leg connection next, and for that I'm going to go ahead and input a roof frame up top here again. So again, I do F2, roof frame, pick my 2 points, and this time I'm going to go ahead and hit strip vertical leg for my connection type. Now, with the way that I input this, we're going to have a little bit of an issue, and what the issue here is going to be is that I input that roof frame. Let me snap to the surface so we can see a little better. I input that roof frame right at the same elevation as my beams, so we can see that top leg just runs right through the beams. Well, that can be fixed easy enough if I were to move it up a 1/4 inch, or even easier that I like to do is upon input, I can go ahead and use my offset controls down here at the bottom of my toolbar. So I know that the primary supports are going to be 4x4 by 1/4 angles. So I can just specify Z plus 1/4 inch. And then go ahead and pick my 2 points, and that's going to upset that 1/4 inch. If any of you paid attention to the elevations, you'll notice that those should be a 1/4 inch different than what they were before. I'm going to adjust my field clearances back to being just a 1/2 inch. And now, when I go ahead and look at that, we could see we don't run into our supporting beams flanges then. Okay, make sure you clear those offset controls when you're done with those. I've got caught by that many a times forgetting to clear that. Other options you have for the strip vertical leg here. Adjust my depth check so we don't see what's behind it again. I'm on my primary 2 support left end. You have a setback, so that setback is actually going to control the distance that this horizontal leg is set back from the center. I think a lot of times you guys want that extended past the center of the beam, so you can input a minus in there, and that's going to actually extend that then. Okay, then you'll see you had an option for your cut radius here, as well as the field clearance that I had used before. So again, go back to 3/4 here, maybe we can see that scoot out a little bit. Okay, how does this detail? It details really well with the version and the templates that I have. The versions that you guys have currently today are not going to detail quite this nice. I just had one of the template writers write these templates and make modifications to the templates here yesterday afternoon to make some big improvements on these. So in a future release, you guys will get these templates and the updated stuff to make it look a little bit better here. So again, what you have currently isn't going to look quite this nice, but we can see that with templates, these do detail out pretty nice. So, okay, erection views. Take a look at erection views real quick. So I'm going to go ahead and detail my roof framing plan, and since all my erection views are created as finite lines, I'm going to go ahead and turn on the Annotate Finite Grid Lines in Place. And if we go ahead and pull up Drawing Editor, go to Erection Views, Reframing Plan. Again, we talked about kind of how that member line is actually created in modeling for us. So when we detail that out in just a stick form, we get our representation there. Really nice. Another thing you can do here is if you want that dimensioned all the time, you can take advantage of dimension only erection views here. So maybe what I want to do is create a couple grid lines here. And adjust that grid bubble setback, adjust this here, and I'm going to set that to dimension only. And then I'm going to go ahead and offset that 5 feet. Okay, make sure my erection view wasn't left open, and then I can detail that again. And then there we see with those dimension only, we'll get nice dimensions for our roof frames as well. So, okay, so that's kind of looking at the detailing and the erection view aspect of how those come out. Just show you a couple other capabilities of the roof frame. I mentioned corner openings, that we can do corner openings. So just a couple different scenarios here with that. And let's see if I come here and here. And the way I'm going to do this is I'm going to go ahead and set my secondary quantity to 0. I'm going to go back to a saddle clip connection. In this case, my primary two connections and settings don't matter because there won't be a primary two created here. Go ahead and say OK. And there we get that. I need to go back and make adjustments to those saddle clips because it's remembering when I did the offset here. So I'm going to go ahead and set that length of angle to 6. I'll do my horizontal offset back to auto. The other thing you're going to watch for here is the opening side of this roof frame. So right now, in this case, my angle leg goes in maybe towards that corner opening. If I need that to go out away from the opening, I can just use my opening side and set that to far side. The way it works is that toe direction is always going to point out away from the opening side. So you can use that to change that. So that's a simple corner case that we might have here, and you'll notice that these beams, some of these beams are sloping. So this one here is sloping, this one here is flat, and it does appear to get most of that correct there as we input that. So it is pretty robust as far as figuring out the slopes and everything that it's connecting to. So just a couple other examples here. We can do it to joists, so maybe over here where we have some joists, we need to add an opening in. We can do that as well. So I'm just going to go ahead and add a couple construction lines in there to look at a few different things. And actually I need to set that so it's not a finite construction line. That way I get my correct intersection points. Okay, there we go. And we can do this again, just a secondary quantity of 0, and we'll do opening side is going to be far side again. Something to remember with this, since it is a custom member, the first point that you pick is going to be considered the left end of your member, and the the second point that you pick is going to be considered the right end of your member. So in this case, we can just see that we can connect to the joist there as well. You could also do something a little bit different. If we come over here and look at this, the two connecting supporting members are 90 degrees to one another. And if I just go ahead and set my secondary quantity here to 2 in this case, and I'm going to set the opening side back to near side, okay, it is going to figure out all the geometry there for us and connect there nice like. Just one other example of that, I'm going to go down to a different view where we have more skewed members. And in this particular case, I'm just going to go ahead and frame between our two members here. And we see it does, again, figure that out properly, connecting to those two skewed members. One thing to take note of here in this situation is when I picked the points, I picked my first point up here along grid line 2, and my second point was along grid line 2 as well. My secondary supports are going to be located from that first point that I picked. So if I look at the edit window, I have the secondary supports set up so that the first one is 1 foot. Again, that's from this left end, and then the next one is 4 foot from this one. Where that's going to concern you, or where you might want to watch out for this, is if I were to have picked my points along where the longer primary support is going to be, I'm going to see my secondary supports get located a little bit differently then, just because it is based off of that first point that you picked. So just to kind of show you that, and I'll flip my opening side. Okay, now my secondary supports are located off this left end instead of this left end. I would want to go ahead and make some adjustments for that. So maybe I can go 5 foot and 5 foot. And there we have something a little bit better. So just something to watch out for and be aware of as far as how you're picking your points and how the different things are located. So that's it for the roof frame member. If you guys do have any questions on that, hold them to the end or put them over in the questions pane on your GoToMeeting window there, and I'll try and get to those and answer those when we're all completely done here with the webinar. The next thing we're going to look at is our part library. So the part library is something we can utilize to import maybe buyout items, Hilti anchors, safety gates, different types of things. Just about anything that you could think of that there's a DWG, DGN, or IFC file out there for that you can get your hands on. And we could import this into our part library, and then we can add that as material or members in any of our models so that we get that information more accurate in your model. You'll get that information then transferred over into your bill of material and different things like that. So like I said, just a good place to organize different buyout items or anything else that you could import using a DWG, DGN, or IFC file. So where we're going to access part library is through utility functions. So if we go into utility functions, right-hand side here, we have part library management. And the first time we come in here, there's not going to be any thing in here. So what we can do is we can create different libraries to help us organize all this stuff. So maybe you want to have a library based on the manufacturer of the part, or maybe you just want to have a library for all the expansion anchors you're going to use. However you choose to do your housekeeping, you can really do it here. I'm going to show, in this case, I have some Hilti anchors that I'll bring in. So I'm going to create a new library, and the library name, I'm going to call Hilti. Just expand this window a little bit. So our library is blank right now. As we start importing items in here, we're going to see on the left-hand side of this window, this tree kind of start to get populated. And we can also right-click in that tree. Maybe I want to create a subfolder in here. So maybe I have Hilti, and then maybe I'm going to have, in this case, I'll just do a subfolder for expansion anchors. You could do different subfolders for any different part than that Hilti makes, maybe. So I'll create a subfolder, and the folder name I'm going to call it is just expansion anchors. Okay, and then I can right click again and hit import new parts. And I just have these parts in a folder on my desktop for now. Notice I have 3 different ones. I can pick them at the same time using Control or Shift. Just your standard Windows selection to get multiples, or I could do one at a time, however I need to do it there. Okay. Then when your import options pop up, the information in here for description, manufacturer, part number, that stuff currently is just going to be blank. Once we get them imported, there will be some standard information if it's available in that file filled out for us. So I'm going to leave those blank for now. Your weight here is indicated as 0. Now, we did make some changes to this weight in previous versions. The weight, when we go and add these things to the model, the weight would be calculated for you. Well, that's not really accurate because the way that it calculated it wasn't always, we didn't know like what materials it would be made out of or anything like that. So the density of your materials could be different, making the weight that we calculate incorrect. What we've done here now for changes is we just give you the option, you set the weight, and that's what it's going to be when it gets input to the model. And we're not going to calculate that at all. So maybe these expansion anchors are, I don't know, 2 pounds a piece, something like that. You could choose to rotate that, change your origin point, translation options, scale factor. I'm not going to change any of that. I'm just going to go ahead and say import. Okay, and now notice on the left-hand side I get those files and the names that I input there. And as I pick those, we're going to get a preview over here in this little screen that shows us what that part actually looks like. The blue, red, and green lines indicate to us the X, Y, and Z axes. We can turn that off with the show origin axes here. You can change your views by hitting the buttons here by the axes that I just turned off, or if you just left click, you can rotate around a little bit. So just a real basic little viewer to give you some sort of preview of that part. Then you'll notice down here at the bottom also you have a description that was filled out, you have a manufacturer, you have a part number, and then I have the weight, and below here we have the length, width, and height that is filled out for us. Now if I want to change any of that, I can hit Edit Part Info over here on the right, and then I can make that change. One thing to be aware of here is when you add this into the model, the description that is going to be filled out for the material is going to be a combination of the manufacturer and the part number. So right now, the way it's set up, when I add this, I would get unknown Hilti 371793 as my description. That might not be what I want. I may just want Hilti without the unknown, and then I can modify that, so then I should get a combination of that, and we'll see that as we add this into the model. Could adjust your weight, change the rotation, your origin point, translation, that type of thing. I don't need to change any of that, so I'm just going to say update. Then I'm going to go do the same thing for these other 2 that I had imported here as well. Okay. Uh, Now, like I said, you could create more folders in here and do different things, bring in different parts, that type of thing. What I'm going to do now is just for one more example, I'm going to create a new library. So I'm going to go ahead and hit Change Library. You'll notice that I didn't hit Apply down at the bottom, so it recognizes something changed when I did that, and it's going to ask me to save it first. I do want to go ahead and save those changes. Now I could select an existing library, or I'm going to create a new one here, and this one I'm not going to do by manufacturer. Maybe I'm just going to call it Safety Gates. I'll go ahead and right click on the left tree there, say Import New Parts, and I just have one example here of a basic safety gate that you may use. Again, same process. Maybe the weight of that needs to change. Maybe it's 15 pounds. It's just a small little gate, so. Okay, so there we have something like that. Again, you can go into your part info and change this. So I'm going to get rid of that manufacturer there. Actually, you know what? Let me leave that in there so I can give you an example of how that kind of shows up. So there now we have a safety gate. Again, you can change your views, look at your little preview. There's your length, width, and height down at the bottom again. So that's really the basics of importing here into our part library. Uh, the part library is a global item to your data directory. It is not job specific. So if I change out of this particular job that I'm in into another job, I'm still going to have all the same part libraries available to me in every job that's using that data directory. So, okay, I'm going to go ahead and close that. And I mentioned that you can add these in modeling as either materials or as miscellaneous members. I just have a couple real simple examples here. So over here, I have an end plate, and maybe that's framed into a concrete wall or whatever it is to add my expansion anchors in here. So if I hit F3 for my material add prompt, pick the member I want to add it to, I have library part down here. It's going to ask me to select a library, so I just have to select a library on which one I want to add. It's going to be the Hilti, and then I could go ahead and pick whichever one is required here. Okay, pick my insertion point. I'm going to pick the same 2 points, that way it goes into my screen from that reference point that I saw in my preview. Can rotate it around if I need to, just like any other material. Locate a reference point. I'm going to go ahead and right click to return. Then it comes back to my part library, so I could continue adding if I needed to. Okay, so there we get our Hilti anchor. It is, it's added as just a standard part material. So if I go back and edit that, all it is a standard part material here. There's not a lot of intelligence or anything to it. If I go to general information, we talked about our description. Notice how I updated that in there to be, and I told you it was the manufacturer plus the part number that makes up the description currently. The weight of your item here is the 2 that I had specified in the part library as well. I could copy this around just like I could any other material. Let me change my selection filter back here. So if I grab that and say copy material, maybe I'm going to do a fill option. In the X, I'll go 5.5, which should be my standard gauge for 1 copy. And then in the Y, I'm going to go 2, my Y spacing is going to be -3 with 2 copies. Locate the base point with the copy material. I can just return, confirm yes, and there I have all my expansion anchors in there then. Okay. On some of these, beware that when you do detail the members, You can see, like with these expansion anchors, there are a ton of polygons on there, so just beware that it may take a little longer to detail some of these things. I'm going to hit show detail on that so we can kind of see how it comes out in the detail. I'm not going to detail using templates. And while I'm waiting for that, for time purposes, I'm just going to come over here and give you a basic example of one more thing, adding that safety gate. And I'll just add it as if it was a safety gate for these stairs. The width isn't going to be quite right, but that's okay. This one I'll add as a member. So I'm going to hit F2 and we should have a miscellaneous library part. It's going to come up and it does remember the previous part library that I used. So what I may need to do is hit the change library up in the upper right, grab my different library, in this case safety gates, pick the one I want to add. Okay, and I'm going to actually use my Z offsets here again. And let me go back and adjust my depth check. I'm going to cancel that. I need to change my depth check here so we can see what's actually happening there. Remember, add prompt again, library part, okay. Okay, now we get my rotate material, we see that. And I'm going to go ahead and rotate this a little bit. Bring that up in a little better position. Click OK. I'm done adding, so I can cancel. And if I rotate around, kind of see a little bit of a safety gate there. So again, it's not perfect. I didn't get the correct width of gate for this, but we kind of get the idea there what we can do with our standard part or our part library management then. Just to go reinforce that description thing, I'll edit this material. Notice here now for that description we have an unknown. That came from the manufacturer because I just left it as unknown. One thing to remember about these things is once you add them to the model, they're in there. They're not really like linked back to that part library at all. So if you were to delete something out of the part library or whatever, it's still going to be in the model here. And, you know, sending a model off to somebody else, these are things that are in the model. So you don't necessarily have to worry about if they have this particular part library or not in their data directory. It's a part of the model and should stay in there. So our detail is done here, so we can kind of take a look at that. Here we have our Hilti anchors. Take a look at the bill of material. We got a total quantity of 6 of those Hiltis. Calculated the weight correctly based on the quantity and the weight that I had input. One thing that some of you are going to be looking for is for some of these things to maybe act a little bit more like bolts. Maybe you want them to act like field bolts to where they're in the model but they don't show up on the detail. They just get bill of material and weight information. So things like that, you know, we are aware of. This is kind of something that's in its infancy.